Right, question 4, part C, part 3. We have cans with an average. We've seen this before anyway, but we've cans an average weight of 1,000 grams, and they're normally distributed about the average value. So there's 50% less than this, 50% greater than 1,000 kilos or 1,000 grams, and the standard deviation is 12 grams. Part 3 here, determine the percentage of cans containing between 985 grams and 1,130 grams. Now we already have the Z scores worked out in the previous two parts for this. For this we got Z equals minus 1.25, and for this guy here we got Z equals 2.5 plus 2.5. So to determine, now we're looking to determine the percentage of cans between these two limits. And on the Z, when these are standardized, that's what we call this, we standardize these two weights into Z scores. So we need to get the probability first that Z is less than 2.5, less than or equal to, or whatever, it doesn't make much odds, and greater than or equal to minus 1.25. Right, so our wee curve will look like something like this. Is very poor, but anyway, you get the idea. 2.5 is out here, and minus 1.25 won't be quite as far back, it'll be somewhere here, right? So that's minus 1.25. So we're looking to get the area between these two limits, which is this area here, added to this area in here, right? And if you remember back from the previous parts, the area between positive 1.25 and the center line, the center here, was 0.3944, and because the thing is symmetrical, this area in here is 0.3944. And remember, we got a very low, this area here was our very low percentage of cans greater than 1,130. And previous to that, we looked up our table and we got a very high area for this piece in here. Something like 0.49, something or other. I forget now, so we're going to look it up. 2.5, right? 2.5, there we are, 0.4938. So back to the drawing there. And that's 0.4938. Right, so we add these two areas together. 0.3944 plus 0.4938. Let's see what that comes to. 0.3944 plus 0.4938, and I get 0.8882, and that represents the area under the normal curve between positive 2.5 standard deviations and minus 1.25 standard deviations. So it's a lot of it, because the whole curve will come to 1, and this is going to be 0.88, right, almost 0.89, right? And we need to convert that to a percentage. Well, to convert this area here, this is area under the curve, to convert that to a percentage, you multiply by 100, so bounce a decimal point, 12, and that becomes 88.82%. So in our case, we would expect 88.82% of the cans coming off this production line, if you like, to weigh between those two limits, 985 grams and 1,130 grams.